see, this is what, Thursday? We aren't yet at the end of the week in this class. The stat class finished its week today, but we're doing a little bit of follow-up from yesterday where I ask everybody to select typical problems from chapters 4 and 5 that you might consider a test type problem, and to see what you selected. And we're going in the idea, if you look at 3 chapters, 7 sections per chapter, that's 21 problems, and we're going to do 20 in the test. So if you look at a problem in each section, you should have a pretty good idea of what you're going to have to do. So what we'll do is we'll start with section 4, and we're looking at problems where you're combining polynomials. So this is 4.1, and we're just looking at a problem now that would say I have polynomials, I'm supposed to combine them, and let's see if I can sort of get this one up high. And that's a long problem. Good grief. Well, I think I'll do it piecewise. Okay, this is from 4.1. Now this problem is to go ahead and subtract, and I'm going to slide over. So you can see you have a trinomial. It's a top problem there. So if I can find my pen for showing things that I want, and I've now managed to misplace, I'll go to the blue one then. We'll just do it that way. But what we're doing is taking a trinomial, subtracting a trinomial, and then I'm going to slide over, and then I have what? Subtracting off the sum of 2 trinomials. Get the idea? So we have a big mess in here that you would simplify first, and then you're going to subtract. And what makes this problem hard is what? The minus sign outside. Slide over, and then in this case, you have another difference, and my guess is you probably want another square bracket right here, because you have a square bracket here, so put a second one here would be my guess, that would be something we want to add in there. So you'd see something like this put in with the problem. Now, I hope as you look at a problem like that, after all the factoring we've done, you can say, okay, I'm comfortable. I know I'm going to combine. I know when I subtract, I change the signs. That, I think, is a reasonable level of difficulty. Let's look at somebody else's section 4.1 and see what would be different about it. Now, this was a little different idea. This is a case where the difficulty level is a little bit higher because you're adding 2 trinomials, but what has happened? You've gone to fractions. So this is a trade-off for having a lot of terms with minus signs to just a straight addition, and then you have to change to common denominators in order to pull this off. And that would be another approach to the problem. I'd say the difference in that one, I'd be more inclined to give it to you on a horizontal, the first plus the second, rather than one on top of the other. But 2 different levels of difficulty there. You're trading off fractions for terms. Let me go to another one. Okay, interesting. Now, this tells me something because, in a sense, you are, in this problem, dealing with the same concern about fractions. Because in both cases, you're having to find common denominators. Now, that increases the level of difficulty, right? As opposed to just a lot of terms in parentheses and brackets. And let's see if somebody else has, okay, here's another number 4. 4.1 still. And see if I can get it up high enough. Again, I'm just going to come down and do it in pieces. Here's the problem. You have a, let's see, yes, a trinomial. And then what? As we slide over, subtracting off another trinomial. So that's sort of in between the first one, where we had what? A difference, and then a difference between the differences. Looking at difficulty level, I'm not sure I would be quite as concerned giving you fractions on a test problem, although the common denominator idea is a good one. But I'm not sure I'd push that on a test. And the first one seems just about a little more difficult than I want to choose. So this one right here, as we come back and look at where we have something with different variables, has a level of difficulty, and you might argue, okay, in a sense, this problem, because you have A's and B's, is going to be maybe at a difficulty level that's actually more than that first problem we showed. So I don't know. As we come off there, that's a tough call. But I would say something like the first one or this last one in that group, to me, is more appealing than the fractions on 4.1. Let's see, another section 4.1. Okay, this is section 4.1. I've got to stop and look at what I have here now. Okay, that would be perhaps more with products. Okay, let's see another section here. Now this is, I'm trying to figure out what I'm doing here. Okay, number 59 again, and this is in 4.1. Here's my problem. And it involves a subtraction and then doing what? As a vertical subtraction. And that one is very similar to the last one I showed, but we just have it in terms of one variable. But you're getting the idea of the kind of problems in 4.1. I think probably looking back, the first reaction is I can do it. Second reaction is no problem. The danger, you don't practice it. If you don't practice it, a little careless error in signs could chew you up. Okay, let's take a look at 4.2. 4.2, here's the first example in 4.2. This is where you were simplifying exponents. And I'd say that's my first reaction in this 4.2 is reasonable level of problem. The key here that you have to be careful of is what? The one missing here, the one missing here. And then that you do what with the exponents as you come across? You multiply them. And also this 2 to the first. So that problem, I'd say, is a fairly realistic level of what I would see in 4.2. So let's come off there. Let's look at somebody else's 4.2. In 4.2, okay. Another 4.2. Again, very similar problem, very similar reaction. The thing that makes this one a little more difficult, you've traded in a numerical value for what? This minus sign and this minus sign. You have to be careful because when the 2 is up here, that'll give a positive there. When the 3 is up here, that'll make that a negative. One way around that, treat that as -1. Treat that as -1. Then you're multiplying through, again, a very typical problem. That, again, is at about the right level. Okay, so coming off there, that was in section 4.2. And that, I'm trying to, okay, I don't know what page number that reference is, and that's part, 241?
Number 77.
Okay, this is a similar problem again. This one would be at a little lower level of difficulty. The key here, you're focusing on what? The -6 times the -7. That would be a little bit easier than I think I'd put on a test. So you can get a better idea of easy or hard there. Let me go back to, let's see. Okay, we're still dealing with products, right? I don't think we're trying to think how, well, this may be. This is sort of, this would be, I don't know, I got mixed feelings in this one. Because now we have a negative exponent and we have a quotient. And I think that's realistic also. The first and this one, both are realistic. This is going to push you a little bit more in negative exponents, but I am comfortable with this problem also. So the first and this one I'm very comfortable with. So that is a case where you'd have to go ahead and know how to handle the negative exponent. Now the usual problem, let's come back to that for a moment, because there is a caveat here. What are you told to do? Write your answer with positive exponents only, and that makes it a lot harder. And again, the one that's missing. So you have up here x to the first that's missing, and the y to the first, those would be very important. Okay? So as we come off that, and I'm looking at 4.2, Okay, I think we looked at that one. And looking at another page here. Okay, I guess in a sense that's more like 4-5 is what I'm seeing. Because here's a problem from 4-5 that's just like the one we looked at a moment ago. So that must be section 4-5. And that is, again, a very typical problem from section 4-5 because we're dealing with negative exponents. Again, the key, when you see a variable without an exponent, indicate the exponent, bring the exponents in from the outside, and then simplify with positive exponents. But that, again, good level of problem. Let's look at something from 4-3. This is looking good to me also, although maybe a little bit harder than even I would go for. Okay, here is a mess. You're going to, that would be harder than I would give in a test, but you can see what's involved here. If I gave you the first 3p cubed times this last trinomial, that would be more typical of a test problem. Or, I just can't see where I give you something like a binomial times that trinomial that put you quite through that much. But that's a little bit harder than I would push for, so let's come off there. Another 4-3. This, if I were going to go to 2 multiplied together, let's look at this one. This appeals to me a little bit more as a typical problem because you have what? A trinomial times a trinomial, and what are you being forced into? You can't use FOIL here, so you take each of these 3 terms and multiply it times the trinomial and add together. Very typical problem from 4-3. The next one you see with using, now FOIL was not part of this as much as the distributive property, but what makes this one harder? The fractions. But I'd say both of those are pretty realistic. I'd be more inclined maybe to the first one than the second one. But again, that was in section 4-3. Let's see if I have another one in 4-3 that I can share with you. Okay. Here's another one in 4-3. I think that gets a little bit more to the, that's interesting. A couple of you picked the same problem. I just noticed that. You certainly were impressed by the difficulty level of this one. This is that 47th problem. Same problem. And I appreciate your willingness to put yourself in the rack. That's a little bit more than I would expect. But I think I might go a little bit more than the previous problem, which is pretty straightforward because even though you may multiply that out using the distributive property, it's easily done with FOIL. So again, that's a tough call as to what's typical. I'm looking to see if I have anything else in 4-3 that I can share. 4-3. Okay, I'm looking here. Okay, that again. 4-3. Okay. I don't see anything else there in 4-3 that catches my eye, the share. Now, 4-4. I'm trying to pick up a problem from section 4-4. And this is where we have what? All the special products. So just looking at a couple of them here. This is a sum and a difference. So that's a special one with FOIL. That works out rather nicely. And come off there for a moment. A whole series of problems like that. Now this one I think is realistic. This is sort of a nice touch on that one, a little different. See if I can get it flattened out. Okay, Debbie. Notice where you would take the product of the binomials first and then multiply through by the or that single factor of p in the outside. I like that one. That appeals to me as a good level of difficulty without making it so darn easy. I mean, if you just have 3p plus 7 times 3p minus 7, you're not really having to reflect them very much, and I think that's a nice little transition. So we'll come off that. Now we're still in section 4-4, and I need to hunt for another problem in 4-4. Now this page skipped 4.4. And this is chapter 4. That seems to have skipped it. Let me see something else here. With that same idea in mind, here's another way of writing the problem. 5x minus 2y quantity squared, that's your trinomial perfect square. And I think if I were going, reflecting on the test, if I saw something like that, I think I'd be inclined to have an A, a B part. A would be a little bit more straightforward, B a little bit harder. So the harder version might be the one where we had the letter P outside, and so you had to bring in one extra factor. But that gives you a pretty good idea on section 4.4. Section 4.5, we talked about that already. 4.6, here's an interesting problem from 4.6. Nice level of difficulty. I like the choice here. Just a minute, Debbie. This slid down on me about the time. Now we can go. Notice you have, 1, 2, 3, 4, 5 terms, and you're dividing everything by minus 3r, and you can see how it's set up. I like that. To me, that seems like a very nice level on 4.6. That's problem 23 on 4.6. So as we come off there, let's see if we have another one from 4.6 that is of a similar level. Okay. Number 8 in 4.6. I'm curious there. Is that supposed to be 2x in the denominator? This is number 8.
Yeah, it should be
2x instead of a 2t? Okay, because if it was 2 times t, that would be not a pleasant problem. But as 2x is a nice problem. And that, again, is a nice level of difficulty. But look at 69 right below it. You can't see the 6 there. I'll slide over. But looking now at this problem, what are you forced to do in this problem that's different from the one above? These are two good examples. Long division. And yes, I'm going to have something with long division. Now, whether I run an x squared plus 3 in that particular case, or let's see if I have another one. Well, again, let me show you another one that's here, very similar in nature. And this might be a little bit better, and only because of what? 3p plus 1, you have a p to the first in the divisor. This appeals to me a little bit better rather than having a 3p squared or something. So that is rather nice. Again, that's number 61. Now, contrasting to that on the same page, here's one that I think ups the ante a little bit, because you're dividing by 4t squared plus t minus 3, and now you have a trinomial you're dividing, and that seems to me to be a little bit more pressing, but in either case, very comfortable. The one right above is probably beyond what I would push, just because there's a few more terms in it, I think. Or is there? About the same, isn't it? It just seems, for some reason, the x's seemed a little more jumbled to me than the t's. That's an interesting thought.
That would be easier because it's all pluses as opposed to...
Okay, good point. The denominator on the top one is all positive, which may be a little better wrinkle, and you have all positives in top. So the second one, just because of the minus signs, is going to be a little more difficult. You get the idea, though? A division. And I have, let's see, again, looking for variations in that as I look at different pages. Okay, let me look at another page here. Now this is, I'd say, in terms of a problem, this just happens to be 19, where you have 3x squared on the outside, and it needs to be rearranged, and the rearrangement is the trick here, so that you put your 6x cubed first. So this should be over at the beginning like shown down here, so you have both of them in decreasing terms. That's a kind of misleading give you something like this and expect you to get yourself in trouble. But the key is both in descending terms, and that would be, again, a little less level of difficulty. Okay, that was for what? 4-5? 4-6. Let's see if there's anything else. 4-6. Here's an interesting one in 4-6. Boy, if I wanted to really get you on negative signs, this is a nice one to do it. You've got enough negatives in there to give a good measure if you know how to handle them. So that's a nice one too. And again, I think if I did something like this, I'd have maybe the problem you just saw, that happens to be number 23. That would be the first one I give, and then the second one would be a long division with the next, say a 3b plus 1 into some kind of polynomial. So I essentially expect you to do long division. And my problem is I'd not like to put all the weight on one problem for a section. So even though it would be 5 points for each, maybe a simple version at 2 points and a harder version at 3 points. So if you get the simple ones on those where I have to double up, you get points for the problem, and then maybe partial credit in the second, and so you're getting better than half credit on a particular problem. Now the downside of that, everything you do takes time. And that makes it a little more difficult. Okay, now we're into 4-7, is that right? 4-7. Where do we have in 4-7? I'm trying to, just exponents, scientific notation. Okay, let's see. I have several of them I'm looking at here in scientific notation. This is definitely a place where I'm going to be inclined to go to an A and B kind of thing, just because now what's being done here, okay, let's try this one. Top, middle, or whatever you call the screen there, you have 9 times 10 to the minus 5. Now I'm assuming that what was done here wasn't the original problem. That is, this became, as you brought it up, a plus 1. So you had minus 5 plus 1, and so that's part of the solution right there. The original problem, I'll try to block that out, was something like this. There's another one right below the same idea. Now I'd say they need to be, certainly that's not a bad A part, but not difficult enough for a B part in scientific notation. So if I went to a scientific notation in part B, I'm looking for a 4-7 here. 4-7s, 4-7s, 4-7.
It's an A, B, and the last should be the last problem.
Yeah, I see the, okay, let's see what we have here. Well, we'll see. Okay, this is again that same idea, consistency among several of you, but I think I'd like something maybe with 3 or 4 different factors involved, a little more work than is shown here. And I don't know if there's a problem that's that much more difficult. I'm looking again at what's been provided, hunting for something in scientific notation that goes beyond that, and not finding, well, let's try this. Nope, you neglected to some extent scientific notation beyond the level of difficulty which I just covered. Here's again, same idea. But I think, isn't there in that section something a little more involved with that in the problems? Or is that as bad as it gets? That's as bad as it gets? I can make it better than that. I can make it better than that.
It gets worse.
But the example I gave in the board in lecture, where I had maybe 2 different products in the top with, well, let's see, on the back, or I will add to a book here. Let's see, 3.2 times 10 to the minus 3 times 6.4 times 10 to the second over, let's say, 19.2 times 10 to the minus 4. This is a little bit more what I have in mind. Okay, to the extent you have to do what on top? You have to add your negative 3 and your 2, then you have a negative 4 down here. But you can see the 6.4 and the 19.2, so that's a factor of 3. So you have 3.2 over 3. So it's not too shabby. And if I had just left this as a 3 instead of a 3.2, this would have all gone to 1 times, and then I would have had a 10 to the 6th, a 10 to the minus 3, and I have 1 times 10 to the 3rd, and I have 1,000. So if I rig it properly, and maybe make this 3.0, then it rigs very nicely, and you would just get 10 to the 3rd when you're done. That is more typical of the kind of problem I would see, and I guess I see you're looking at one at the end of the section.
In the review section, it doesn't have the decimals, but it's a little more
Similar,
like that.
yeah. And what page is that on?
That's on 282,
282,
number 76.
76. So 282, number 76. Okay, let me just put that up for you. 282, number 76. Very similar in difficulty level. So in fairness to you, that's more what I would have in mind. So that was chapter 4. Let's see what we have in chapter 5. 5, our focus is factoring. Is that right? Yeah. Okay, here's one that I think is reasonable. Very reasonable in terms of a request. This is where you have to group to factor. This is grouping by pairs rather than putting it together. If you collapse the 4p and 3p and get 7p, then that's a pretty much straightforward because you're going to have p plus 4 times p plus 3 with FOIL. But doing what's shown here. And this is the one Jennifer was asking about, very similar. Here's a case where you have p plus 4 in a little bit easier form now. And this pulls out to, we can't see it there, I'll slide over, p plus 3 times p plus 4. That, I think, is a typical factoring that, yes, I would expect you to be able to do. In the same way, while we're talking about these problems of that type, 71 in the same paper, probably, if we look at difficulty level, do you understand how much more difficult that one is? Just because of the way the variables are? So I think the first one I'm more inclined to see as mid-range. This seems to me to be a little bit harder, but it's a possibility. Now that happens to be number 71. Okay, so we'll come off there, and let's see if I can find similar type problem. Interesting, again, the focus, that happened to be 71, and here is, well, I guess it's, wait a minute, that's puzzling. They're the same problem, but labeled differently. This comes out 80. But you picked the same problem, just numbered differently, and I'm not sure which number is correct. But certainly, what you're seeing here is the last one on the screen is more difficult than the one above. I would not give you the one above. Are they the same problem?
Yeah, they duplicated it.
Interesting. Okay, so we caught a duplication, but 2 people selected the same problem as a good problem to select. We found a little glitch. Well, that's okay. Now that again is in factoring by grouping. Here's the same section. This one is 75, and that's, now there's something I like about this one because this is sort of in between the difficulty levels. I'm impressed by this one maybe more than I was the other 2. So this one at number 75 seems like a nice in between. Okay, so we'll come off there. That was number 75 if you're just making notes for yourself. Let's see what else I have here in chapter 5. Now note the similarity here. This is factor completely, but is without the 4 terms. So what are you looking for here? That GCF. Now that seems to me like a good A problem, where the other, if that were in the same set, would be a B problem. So if you have, and that, I don't have a number on that.
That's in the test at the end of the chapter.
Okay, chapter test at the end. But in chapter 5, that is a GCF. Now, I'd say a GCF is a good A part, and a B part grouping by 2s. Might be a nice way of pulling that together. So those 2 in combination, doing a nice job of separating it. I'm looking for, again, similar problems. Here, interestingly, in 69 in this selection, again, a similar by 2s, coming off there, very similar. Here, interestingly, boy, you folks nailed this very well. Here again, this is number 11. Same idea. Now this appeals to me because of Jennifer. This is Jennifer's special. This is her problem. Okay, and I like that one. So thank you, Jennifer. Now she didn't turn this one in. This is just one that is, let's come back and look at one more time because that's neat. Let me bring that down just a little bit. Because we have focused on that so much, that appeals to me a whole lot. Okay? So read into that what you will. That's number 11, page 317. And notice as a number 11, that's not at the middle of the unit, middle of the problems. That's just an early problem. But that does give me goosebumps. So that's good. Okay, 5-2. This is where I think you started doing FOIL, is it not? In 5-2?
Yes, sir.
Oh, I mean, I could write 30 problems here for the test and have fun and never feel like I was really having enough fun. Now here's a nice version right here. In fact, let me see. Well, hold it, Debbie. Let's see if I can get it. Okay, either one of these. At y squared minus 8y plus 15, m squared plus m minus 20. I mean, you can just do those in your head. That's an easy one. So easy version, FOIL, then come off there. There's got to be something a little more interesting there. So let me go to something with, oh, that's a little more interest. Yeah, that's okay. This is more like a B problem. Now, I don't go along with the separation here. I would not encourage that. So don't read the line below. But the 6y squared minus 5y minus 4 and use FOIL, good level problem. That's nice. So again, that's 23 on page 317. So 2 different levels. That's a nice one there also. Okay, now, still in the same set, interestingly, and this is definitely, you're going to see this. Now, I have one critique here. What's missing?
Oh, 2 to the third.
Well, either the 2 to the third or the parentheses have to be inserted, correct?
Right.
So the simplest way, but notice how it changes the problem? Now the solution was set up right because 2m was as a quantity to the third, so you're going to put 2m. What's the next error you have to be careful about? Note if this is plus, what has to be here? A plus here also, and then the sign changes on this second one here. So be careful. So 2 very, very innocent little glitches there, but it would cost you serious points. Very serious points. Now, what else is missing? I see another error. This should be what? A squared here. If A is 2m, then you're going to have what?
4.
4m squared. Question?
What page is that?
317.
317.
And this is
Okay. But notice the places where you can lose it so simply. And that is what I saw in homework a bunch. So let's come off there. Let's see what somebody else has selected in that area. What section is that?
These are summary
Those are
exercises.
summary.
So those are summary, so I don't know where they're
Those
coming
exercises
from. Well, let's see. In that same category, 315 is, okay, just looking at style of problems, on 315, here's a very typical one right there. You're going to see something like that, and what you're looking for is a TPS, trinomial perfect square, where you have the first term is squared, the last term is squared. Here are the square roots, and notice the product of the two doubled is that. So that's that special factoring. So yes, you're going to have those special kinds of factoring. If I want to, yeah, I'm looking for equivalents here. I don't see anything more there I want to pick up on. Let's see, chapter 5 here. We have a grouping problem. We've talked about that. And greatest common factor. Now we're getting into equations there on that page. I'm looking for things I can share with you. Here's a nice one because this is the difference of two squares. This is one. Very similar and nicely done this time because notice the 8p is in parentheses, the 10 is in parentheses, and notice the last step. Nice move. Very nicely done. Because the 2 was in both parts. That is number 50, and I believe that is on page 317. 317 is that just everything pulled together. And I'm not sure how to address all those, but folks, be ready to factor. Lots. Okay? You should be able to factor everything that we have done. Then we get into what? Equations after that? Is that right? And looking at equations, I'm trying to see what we have here. Okay, looking at a good basic equation kind of problem. I sort of like this one. This is 17 on page wherever. Sorry, I can't give you a page number. Now, there's 323. X squared equals 24 minus 5x. I only have one complaint. I've got two equal signs in the first line. You can't have this one. Now, you rewrite the equation so everything's on the left side, and that's good. And this is nice. And this is nice. And nice, nice. Nicely done, except for that equal sign in that first step. That's a good level for solving. Now, let's see what else we have in solving equations. Okay, I think I've run out of problems. No, hold it. Here we go. Oh, I like this one, too. Nice choice here. Look at this one. Doesn't that give you goosebumps? I like that. Now, what you have to do is expand and get everything on one side. That's a nice problem. Again, when I start feeling goosebumps on a problem like that, that means that's the right level. Good problem for a test. Okay? Nicely done. Now, let's see if I have any others I can pick up on here. 45. 45 from 5-5. Number 45. This one might be, this appeals to me also, but might be a little bit much on a test because you have so much to do first before you set everything equal to 0. Notice your equal sign is right here. That's a good problem, although it might be just a bit on the long side. If I only gave you one, and that was the last problem I was worried about, and I wanted to make sure you were earning your A, that would be the problem I'd probably select of the group. But typically a little bit too hard. Okay, that's as far as this one goes, so I've done everything there. On this one, as far as a problem, this would be a good first level, part A. You have to factor, set the factors equal to 0. Not going to be as difficult as the last one we looked at, so that's pretty good. But that covers those, and I'm trying to make sure. Now, one of the things that we've avoided is word problems. Okay. I'm just looking at the various forms of word or of equations that have been given here. And inequalities. Okay, let's go to inequalities. This is number 7. A plus 6 times A minus 7 greater than or equal to 0. And then you have to do what? Pull regions. Mm-hmm. And we just went through these. This is the last section, I believe, of Chapter 5. Is that correct?
Yes.
The last section of Chapter 5, and that is a good one maybe to finish up here. Okay. You getting an idea? Now, to the extent that you did what I asked you to do, made this work better or not so well. But you're getting a better sense of how to go through and do it? And that's one of the things you do in studying for a test. Select problems, try to do them. And what you did here, if you did select and restricted yourself, now some of you didn't restrict yourself very far, but if you restricted yourself to one problem per section, and then sat down in a group of 4 or 5 of you together with a pot of coffee, or whatever, and sat there and tried to go ahead and then do each other's problems. But I think some of you did a really good job of selection of the level that you need. So, and if you push yourself a little bit harder, that doesn't hurt. Be careful that you can do the easiest problem in the section. You know, you spend all your time focusing on the harder ones. That's why I don't want you to go to the worst one. The middle level seems to be a good way of doing it. Any comments or questions from your part in that? We've spent about the time we normally spend in homework, and I just wanted to cover that today. As Pam noted, we had problems with the Pythagorean theorem. Giving word problems, we didn't do anything there, and as I told you, next week I'll restrict it more to maybe one problem or something that we do as a review. So maybe look through this. We still have tomorrow, but next week thinking in terms of maybe time in the weekend. Hunt for things like we're talking about, and if there's something you don't feel good about, we'll take one a day. So with that said, we are into some new material, correct? The least common denominator. Now I'm just going to look at a typical problem here, the way it was set up, and we'll review it. This was the homework problem I gave you, and it's done nicely. This is done very nicely. This is the factoring. So let me try to bring this down just a little bit tighter. We had 54 and 48. Now you don't see the divisions that would go with this, but this is carrying through the factoring, and you get 3 to the third, 2. Now I would like to see at this point the 1 put there. And then you have 2 to the fourth and 3 to the first. Because you want to build the LCD. And when you build the LCD, you take the 3 and the 2. Those were the primes. And now I can make my next statement. You take what? The highest exponent you found on that prime. Here it was a 1, there it's a 3. On the 2's, you had a 4 and a 1. So this is exactly what it should be. So that means you're going to change each of these fractions to what? The new denominator, and then add. Now what is at the heart of this that I'd like to point out, I need to know what I'm going to multiply times the 54, and we don't do a division. So you look at your 54, it was right up here, you can see it on the screen, 3 to the third, 2 to the first. I wanted 3 to the third, 2 to the fourth. So I'm missing a what? 2 to the third by observation. 2 to the third is what I multiplied here. But I'm doing it by making a comparison here. That is the process we're going to do. Now that's what we typically expect of you in a good pre-algebra. So with that in mind, let's see how we would do a problem of a particular type. And I'm just going to look at what we see in section 6.3, and you're asked to find LCDs of expressions. So I'm just going to pick one of these at random. Here's a problem. Now the nice thing, this is on page 373, number 15. The nice thing about this, the factoring's nearly done for you. Because the expressions have already been written in such a way that you have an a squared, you have a b cubed, an a to the fifth. What's here? B to the first. So really all you'd have to do is what? See, this is 3 times 5. Again, page 373. Now you want an LCD. You have a 3 to the first, a 5 to the first. So if you're going to build your LCD, what would you have? 3 to the first, 5 to the first, a to the fifth, b to the third, following exactly the same argument. So again, that's b to the first, 3 to the first, 5 to the first. So your LCD, 3 to the first, 5 to the first, a to the fifth, b to the third. And that is what you're supposed to do, is just find the LCD. That's it. Any question there? Is that comfortable? Same idea. I'm looking for heads nodding up and down one way or the other. Comfortable in the problem? Jessica? Not really, but we're going to say yes. Okay. Let's look at a little more complication. 34. I need to get the camera head so it's... There we go. 34. Now, I've got a little bit of glare on that y squared, but I hope you can see it. I'm going to write this one on the board now, because we have 8 over y squared minus 5y, and then a comma, and then a negative 2. And what's nice about these, you don't have to do what? You don't have to do anything more than find the LCD. Now, on either of these problems, did the directions say once you find that to change the fraction? No, it's just find the LCD. I mean, you aren't even having to change the fraction. We'll add that in as a step here. What are you going to do here? Factor first. Factor your denominators. Y times y minus 5. And then do what? Put the exponent. What about here? Do you see this one in your head? It's going to be a trinomial written as a product of... Look, if there's any justice, what is it going to have? A y minus 5. Make it work for you. So this, you hope, has a y minus 5 in it. If it does, this has to be a y, this has to be a 3, this has to be a plus. Did it work? Notice you made the problem work for you. Not as hard that way. So what do you need? This is to the first, this is to the first. What are your factors? You have a y, you have a y minus 5, you have a y plus 3. What is the highest exponent you see in each? Done. Now, I can't pass up the next step. I'm sorry. If you were to change each of these together, so you could add them, you want to change them to a new denominator, what would you end up doing? Otherwise, if I have 8 over y times y minus 5, how can I write it so it has this new denominator? Just look for the missing factor. What was missing here? It needs a y plus 3 in it. So what are you going to do? Bingo. It's been changed. What about the next one? You have minus 2 over y plus 3 times y minus 5, and what do you want? You want a y in it. Okay, so let's maybe zoom out just a bit so I can get some room I can move over. I put a y here, and instead of multiplying y here, I'm going to put it behind. So if you were wanting to add these two, we'd usually put this one after this. But if I said add, we don't ever write them this way. But if we wanted to write, then you'd say what? 8 times y plus 3 minus 2y over the LCD. And I'm wanting you to see that we do precisely the same thing we do in arithmetic. Now, if you're going to simplify this and do anything that makes it work, you're going to do what here? Multiply the 8 through, subtract the 2y. So if I bring that up here now, the next step, I have 8y plus 24 minus 2y over y times y plus 3 and y minus 5. This becomes what? 6y plus 24. Notice every time you have to write the LCD, takes a lot of time. But you leave the LCD as what? Factored form. Because what are you really worried about? When that's going to go to 0. So we have restrictions. Y cannot equal 0. Y cannot equal negative 3. Y cannot equal 5. The only thing left I can do is what? I could factor out a 6. Do I gain anything? No. But this is usually the way you would see the problem written for an answer. Now, what is the level that you get to stop in this problem? let's slide, I don't know which camera you can do this on, Debbie, but I went back on the left side of the board here. So if we go to the left side of the front board, this, as I walk over there, I don't know, yes, that's it. You stopped here. The rest is like the rest of the story. This is page 1. That's all you had to do. But that's why we do it, so you can do more later. Let's try one more, and this is a fairly laid-back assignment. 52. Now, I have 15 over m squared minus 9m. So let me write that. That's number 52, and I didn't write down the problem we just did. I'll have to come back to that in a moment. But here we have 15 over m squared minus 9m, and I want it as what? Something over m times m minus 9 times m plus 8. Now notice I have not had the focus on restrictions here. I hope you realize there are restrictions inherent. But this we realize is m times m minus 9. So what's the missing factor? The m plus 8. So if I multiplied top and bottom by the m plus 8, I have the new denominator. So that's just 15 times m plus 8, and they would be the same now, because I would have multiplied top and bottom by m plus 8. I don't know that I have room enough the way I've written that, so I think I'll put the 52 up here and then just say, if I multiply here by m plus 8 and multiply here by m plus 8, I have the LCD, and so the numerator's done. A very similar problem, this maybe if this will help. If I gave you 7 over 15 and said, gee, I'd like that as a new fraction over 45, what would you do? Well, as an arithmetic problem, you more likely would say 15 into 45 goes 3 times, and you take 3 times 7 and get 21. But we could look at it and say, my original problem is 7 over 3 to the first, 5 to the first. And I want it to be something over 3 to the second, 5 to the first. So what is missing? A 3. I had 3 to the first, 5 to the first. I want what? 3 to the second, 5 to the first. So as I look, I'm missing a single 3. So multiply here by the 3 and multiply the numerator by the 3, and that is what gives me the 21. Your old process of doing division to get this 3 worked with arithmetic. If you sit there and say, I'm going to divide this binomial and then do first what? Multiply all this out and get a trinomial, and then divide it by this binomial to finally get the m plus 8, it'll work, but you're just going to beat yourself up doing it. So I'm hoping this comparison is very helpful, because we're just avoiding division. And this set of problems, and go back to the document cam if you would please, Debbie, that's the 52nd problem. I mean, things are still pretty what? Pretty far down the road. Okay, come off there and let's go all the way down to 60. In number 60, now the question, what's missing? Well, if you look at what I have in the first, okay, now again, the first denominator, what do you recognize? Trinomial perfect squared, good. Remember the perfect squared first and last term. PQ is the square roots, doubled. So this is P plus Q quantity squared. And this is P plus Q, but what's in that P cubed plus Q cubed? Boy, that's an awkward statement. Q cubed. Do you recognize anything about that? Okay. Tell me the factoring of p to the third plus q to the third.
P plus Q.
P plus q times p squared minus pq plus q squared. So if there's a p plus q, let's come back to the problem. If there is a p plus q in this, that gives you the other p plus q that looks like this. So you have to think of multiplying the numerator by p squared minus pq plus q squared. That is a tough problem. That is at that level. Put that in a test and you're walking on water when you do that one. So that is a very hard problem. You get the idea? This assignment shouldn't push you very far. So I think having something a little bit light's not bad. So if we think in starting with number 5 through 60, odds. 5 through 60 odds, and it's always just finding the LCD or changing a fraction. This one shouldn't chew you up. I'm hoping it goes smoothly. We'll talk about that tomorrow, and we will, as I say, look at some questions at the very beginning of the hour as part of the review if you do your part on that. So with that, have a very pleasant day. Debbie, what are we going to close with?
We have Neil Diamond, thank the Lord for the nighttime. Does that give you time to study?
Yes, that's when you do your algebra. So thank the Lord for algebra time. I knew that's what it said. Have a pleasant day.